Hello, pre-calc. So here's to do now. Using this unit circle from a couple of days ago, we've got some substitution questions. So in the illustration up here at the top, we've got the vector triangle labeled with 1, x, and y. Last week, you'd identified that the red y side is the same as sine of theta, and the blue x side would be the same as cosine of theta. So we're going to use those to make some substitutions into the Pythagorean theorem. In each case, problem number 1, problem number 2, you're replacing the a, b, and c in the Pythagorean theorem with x, y, and 1 in the appropriate places for number 1. And in number 2, you're going to replace with sine of theta, cosine of theta, or 1. Okay, hit pause so you got that figured out for yourself, and then join me in a minute. All right, so went ahead and made some substitutions. I'm going to call the red side A, the blue side B, and the green side 1. So for number 1, y squared plus x squared plus 1. And for number 2, in the same order, it goes sine squared of theta plus cosine squared of theta equals 1. Maybe you want to switch the order around for which side you call A and which side you call B. No big deal. Either way is correct. So I've written those down as well. Hey, so today, take a look at trig identities. Surprise, same thing we've been doing for the last week. You will be able to simplify trig expressions into a single term, still a learning target. Our strategy, and highlighted in parentheses there, still using trig identities to do this. And the difference for today is that we're going to be adding a new strategy. So a second approach for substitution. Second bullet point here, substitute using Pythagorean identities. And I've highlighted there some of the key clues that we'll recognize visually. If you see any trig expression squared, a plus or a minus as part of that expression, and the number 1. Those are some clues that tell us maybe we ought to try using the Pythagorean identities. So we'll add some more strategies, not all 6 bullet points, but we will definitely add some more. So keep adding this into your notes, but leave some space for more later. Okay, so from the do now, we came up with the Pythagorean identity. That is the Pythagorean identity that we came up with in the do now. Sine squared of x plus cosine squared of x equals 1. The variable doesn't make any difference. You call it theta, x, whatever. I wanted to match the t-shirt. So on the right-hand side there, the t-shirt fake ID. That's so funny. Sine squared of x plus cosine squared of x equals 2. What a joke. All right, so we have started a list of identities in our notes last week. We've got some reciprocal identities, we've got the quotient identities, and so today we are filling in that third section that we left space for. It is actually now. It's not for later, it's for now. And the first one, sine squared of theta plus cosine squared of theta equals 1, or you can write it with an x if you want. The variable doesn't matter. So that is the Pythagorean identity. We're going to fill that whole box in with Pythagorean identities. There are some different versions. Typically, mathematicians would say there are 3 versions, but we're going to do a little bit of algebraic manipulation and come up with a larger set of Pythagorean identities, so it makes it easier for us to recognize what the Pythagorean identity might look like when we come across it out there in the wild. Okay, so here is our first step. We're going to start with the Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. And to start with, we're going to isolate each of those 3 terms, just using simple algebra steps, opposite operations to cancel stuff out and move things from one side of the equal sign to the other. So in this identity, there are 3 terms. Sine squared of x is 1. Cosine squared of x, that's 2. And the number 1, that's our third one. So we're going to isolate each of those 3 variables in turn. So the original equation here already has 1 isolated. It's all by itself on one side of the equal sign. So let's highlight this in green. We'll keep track of our final versions here in green. And then we've got a choice of what to do next. We could either get sine squared of x by itself or cosine squared of x by itself. So I chose, because I already wrote it down, I chose to get cosine squared of x by itself. So I just copied that same identity down again. And then my first step is just to take an algebra step here. So if I'm going to leave cosine squared of x all by itself on the left side of the equal sign, I'm going to need to cancel out sine squared of x. So to cancel it by doing the opposite operation, I need to remove it. So I'm going to subtract sine squared of x from both sides of this equation. So these are going to combine to make 0. So I'll be left with cosine squared of x on the left side. I've already got that typed out here. And then equals, and I'm going to bring down 1 and minus sine squared of x. And that is version number 2. So sometimes in the wild, we'll come across something that actually contains sine squared of x plus cosine squared of x. And we'll recognize that and say, hey, I can make a substitution. But other times we'll see this one, 1 minus sine squared of x. So we'll say, I recognize that one too. And so we'll be able to make a different substitution. And so that's our goal here, is to have in our notes, to create right now, different versions of what the Pythagorean theorem might look like. So we're not like totally confused when it shows up in a slightly different form. We'd be like, ha, I caught you. Here's still the Pythagorean identity. We'll still be able to make a substitution. All right, so let's back up to the original version of Pythagorean identity. And this time, it's going to go too far. This time, let's isolate sine squared of x. All right, well, so to do that, I'll need to get rid of cosine squared of x from the left-hand side of the equal sign. So I'm going to subtract. That would be the opposite operation. The cosine squared of x's, those are going to cancel each other out. So my next line would be sine squared of x equals 1 minus cosine squared of x. And that is the third version of the Pythagorean identity that we've come up with so far. All right. So far, we've only used some simple algebra. We just subtracted something to move one term from one side of the equal sign to the other. So next, we are going to do something a little bit different. So in order to prepare for that, let's revisit, we're going to do now problem here, kind of, or we'll just follow along and do it together. So there are 3 terms here. Let's just look at one at a time. Same directions apply for all of them. We're going to use basic trig identities, the stuff we've been using for the past week, those basic trig identities, and simplify this expression into one term. All right, first up, sine squared of theta divided by sine squared of theta. Well, anything divided by itself equals 1. That's one term. Yay! Cosine squared of theta divided by sine squared of theta. Well, sometimes those squareds are confusing, right? So remember, if it says cosine squared of theta, really what that means is we got cosine of theta times cosine of theta, and then on the denominator, we'd have sine of theta times another sine of theta. Okay, well, if we take one pair of these at a time, cosine divided by sine, that's the same as cotangent. And then there'd be another cosine of theta divided by sine of theta, which also cotangent. So if we combine them, make the substitution first, and then recombine cotangent of theta times cotangent of theta, we could just write cotangent squared of theta. Or if you'd recognize it from the original version, then you could just say, well, cosine squared of theta divided by sine squared of theta. Cosine divided by sine is cotangent. Since both the cosine and the sine were squared to begin with, we'll just make it cotangent squared. Maybe that would make sense for you. Last one, number 5 here, 1 divided by sine squared of theta. All right, well, again, it may be helpful if we expand sine squared of theta to sine of theta times sine of theta. It might also be helpful if we recognize that that 1 in the numerator may very well have come from 1 times 1. Whether it did or it didn't is actually immaterial. The point is 1 times 1 is equivalent to 1, and this is helpful for us because now we can see 1 over sine of theta, that's cosecant of theta, and another 1 over sine of theta, which is also cosecant of theta. So we could just say, you know what, this is the same as cosecant squared of theta. Okay, so remember that. Here is what we're going to do next. We're going to take the Pythagorean identity that we've been working with for the last couple of minutes, and this time, instead of subtracting something, we are going to take each of the 3 terms in the Pythagorean identity and divide it by sine squared of theta. Oh, sorry, it's an x. I wrote an x this time. Sine squared of x. Okay, and so this is a valid algebra operation. As long as you do the exact same thing to both sides of the equation, it's going to stay balanced. Totally valid, right? So I've divided everything on the left side by sine squared of x. I've divided everything on the right-hand side of the equal sign by sine squared of x. So algebraically, this is totally fine. When I simplify each of these, that's going to be 1, like we just saw a minute ago. This one is going to be cotangent squared of x, and this one is going to be cosecant squared of x. Don't forget the plus and the equal sign. All right. Bam. There it is, typed neatly. That is our fourth version of the Pythagorean identity. Right? 1 plus cotangent squared of x equals cosecant squared of x. And it looks totally different than sine squared of theta plus cosine squared of theta equals 1. Obviously, it has different trig functions in it, but that is another version of the Pythagorean identity, and one that shows up, frequently in problems that we'll need to know a substitution. If you come across a math expression that says 1 plus cotangent squared of theta, you'll know now you can make a substitution. That's the same thing as cosecant squared of x. Okay, so this has 3 terms in it also, and our next step is going to be to isolate the remaining 2 terms. So I've already got cosecant squared of theta by itself highlighted in green, but next let's isolate the number 1. We subtract cotangent squared of x from both sides. So even though they both have a variable of x, cosecant squared of x and cotangent squared of x are not like terms. Right? They don't have the same trig expression. So these cotangent squareds, those will cancel each other, but cosecant squared of x and cotangent squared of x, we do not get to combine. They'll just stay separate. All right, and that is our next version. So I got it. I should highlight that, and then we'll get to that next part there, huh? Okay, 5 down. We still got a ways to go. The next job will be to get cotangent squared of x isolated. So in order to do that, I'll need to subtract this 1. Same operation on both sides. These cancel. Cotangent squared x equals cosecant squared x minus 1. Highlight. Okay, there's our 5th version of the Pythagorean identity. Next, we're going to go back to the original version of the Pythagorean identity, and this time we're going to divide each of those terms by cosine squared of x. Oops, wrong pen. Okay, so I'm going to divide by cosine squared of x. I'm going to divide by cosine squared of x. I'm going to divide by cosine squared of x. And when I do this one, sine squared of x divided by cosine squared of x, that's going to give me tangent squared of x. When I do this one, cosine squared of x divided by cosine squared of x, that gives me 1. And over here, 1 divided by cosine squared of x, that is secant squared of x. Fill in my plus and my equal sign. That is version number 6. I had it typed up neatly right here. So I will highlight the neat one. Keep track of these neat ones. Sound effects for my highlighting. All right, tangent squared of x plus 1 equals secant squared of x. That's version 6. So again, this has 3 terms in it. The highlighted version here has got secant squared of x isolated, but next we'll need to isolate the other 2 terms. So isolate each term. Let's do tangent squared of x first. So I can subtract 1. These ones cancel. Tangent squared of x equals secant squared of x minus 1. Yay! So that is version number 7. And oh, I missed count someplace. Oh my gosh, I'm actually off by 1. That is 3, 4, 5, 6, 7. That's actually number 8. Yeah. Up here, this is version number 7. That's version number 8. Whew. Man, we're closer than I thought. All right, and then lastly, there is tangent squared of x plus 1 equals secant squared of x. Again, this time, let's isolate the 1. So to isolate 1, I'll need to subtract tangent squared of x from both sides of the equal sign. These guys cancel. That 1 drops down. Secant squared of x minus tangent squared of x. Highlight. And there is the 9th version. Woo! Okay, so here's what I need you to do. You need to write all 9 of those into your notes. So I grouped mine together, but these 9 versions need to go together. So underneath the yellow highlighting, sine squared of theta plus cosine squared of theta equals 1. I used theta in my notes rather than x. I know we were working with x just for the last several minutes. But then underneath the yellow highlighting, the next 2 are that same set of terms, but rearranged for different terms to be isolated. And then in the green highlighting, tangent squared of theta plus 1 equals secant squared of theta. Okay, so that's like the next Pythagorean identity iteration. And then underneath that, I have the other versions of that where different terms have been isolated. And then same thing for the last one here in blue, cotangent squared of theta plus 1 equals cosecant squared of theta. And underneath that are the different versions where I've algebraically rearranged to isolate different terms. Okay, that is your task for today.